Hey there, Geometry. Thanks for tuning in for an episode of Math with Mullins. Today we're going to be looking at our Chapter 4 test review, and we're going to start with question number 1 right away. The first thing we want to do is go ahead and graph the original points from the figure x, y, z. After we've done graphing our original figure or the pre-image, now we're ready to graph the image, which the translation states x, y plus 2. So that means we're just moving to the right, we're not moving to the right, we're moving up 2. So we're going to take each point and just scooch them up 2 points, x prime, y prime, and z prime, so that it's just shifted slightly above one another, connecting the points. We notice that the translation is still a rigid motion, not changing the size or the shape. The next one we have is x plus 3, y minus 1. So let's go ahead and try this one. Again, we want to plot the original points first and then show the translation of right 3 and then down 1. So again, these are the original points that we had for the one previously, but then to do our translation, we just take each point and go right 3, 1, 2, 3, and down 1. So x prime would be here, y prime is 1, 2, 3 here, and z prime is 1, 2, 3, down 1 here. Connecting the points, we notice that it is shifted to the right and down just a little bit. Okay. Number 3, write the rule for the translation of the pre-image to the image. This does look like a translation, so I'm going to start with C and try to go to C prime. Looks like I go to the right 1, 2, and then down 2. So my translation rule will be x plus 2, y minus 2. Number 4, write a rule for the translation of the pre-image to the image. Again, starting with the letter A and going to A prime, I go to the left 1, 2, 3, 4, and up 1. So my rule would be x minus 4, y plus 1. Number 5, name the vector and write its component form. That just means I'm going from point M to point N. So the name is MN. And in order to get there, I have to go right first, 1, 2, 3, 4, down 2. So the vector would be 4, negative 2. PQ is the name of this vector. To get from point P to point Q, I go right 1, 2, 3, 4. So that's positive 4, and up 1, so that'd be 4, 1. Number 7 is also a vector. This vector is RS. And I don't go to the right at all, so my first number would be 0, but I do end up going down 1, 2, 3, 4. So that's 0, negative 4. Going to the next page, number 8. Graph the polygon with the given vertices and its image after reflection in the given line. So the very first thing I want to do is plot all my original points first. So let's go ahead and do that. So here are my original points for A, B, C, and now I'm going to reflect across the y-axis. Again, this is the y-axis, so I'm just going to count how far is each point away from the y-axis. A is 1 step away, so I'm going to plot the point 1 step to the left. B is 3 steps away, so 3 steps on the left. And C is 4 steps away, so 4 steps to the left. As I connect those points, you should see a reflection of A to A prime, B to B prime, and C to C prime across the y-axis. The next one, we're going to do another reflection, but now our given line is y is equal to 3. So just keep in mind, here's going to be your reflection line. So that's one thing that you always want to go ahead and determine where your reflection line is. It's best to maybe use a highlighter or a different color than your pencil given. The first thing we want to do is go ahead and plot our original points of the pre-image. Interestingly enough, 2 of our points are already on the reflection line, so F prime and E prime will not move at all, but G and H will. H is approximately 3 steps away from the reflection line, so it'll be another 1, 2, 3 steps away on the opposite side. And G is also 3 steps away, so 3 steps away it is for G prime. Once we graph this, we should see a reflection across that y is equal to 3 line of H prime, G prime, E prime, and F prime. Okay. Number 10 through 12 starts with the lines of symmetry. And for the number 10, we notice that there are two lines of symmetry, one horizontal and one vertical. For number 11, there's only one line of symmetry. And for number 12, there are no lines of symmetry. So none for number 12. The next one we see is graphing a polygon with the given vertices, and then we're going to rotate counterclockwise about the origin. This is 270-degree rotation. So if you remember from our notes, 270 degrees means we're going to change A and B to where they switch to B and A, except A will now have the negative. So if that was an XY, it'd be Y comma X, where the X gets changed to its negative. So first, let's plot our original points, L, M, and N. Okay, so here's our current figure. Remember, I want you to think about rotations as hands on the clock. So we have 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. And this one's around 3 o'clock, so that means rotating 270 degrees counterclockwise should be right around 6 p.m., so down here in this quadrant. Let's go ahead and see what happens to each of our points first. Right now, L is at 1, -1. So for L prime to change, we're going to switch around -1 and 1. And the letter A is the one that's going to end up changing. So the X value will now change to its negative. So that is -1, -1. Okay, so I probably should do this in a different color. So then we look at the next one. M is currently at 2, 3. So to show M prime, we're going to switch around 3 and 2. And the letter X, which was the original 2, is going to change to its opposite of -2. So 3, -2. Here's my M prime. The last one is letter N. N is currently at 4, 0. N prime will switch around to be 0, 4. And now this X value of 4 is going to be changing to its negative. So 0, -4 ends up here. And if you connect your points, it does look like the rotation has turned it all the way around to be around the 6 o'clock mark. Next up, we have a 90-degree rotation. So let's go ahead first and talk about our original points and where they are. -3, -1 is A, 2, 2 is B, and 3, -3 is C. A 90-degree rotation, if you remember, is where B and A switch, but this time B is changed to its negative. So if you are thinking about your X and Y values, that means Y is now going to change to its negative, where X would stay the same. So here's my original figure, ABC. So to change A to A prime, A right now is at -3, -1. So A prime, I'm going to switch them around, -1, -3, but now my Y, which is the original -1, will change to its positive. So A prime is now at 1, -3, which would be down here. Okay, this one is really just going to rotate around itself counterclockwise. So A was at 9 p.m. and now it's right around 6 p.m. C is in between 6 and 3 p.m. So C is probably going to end up being between 3 and 12 p.m. And B was close to 12 p.m. So it's going to be probably close to 9 p.m. by the time we rotate it. Let's see what happens with B. B was currently at 2, 2. So B prime just means they're going to switch places. And the X value, which is this original 2, is now going to become negative in the back. So 2, -2. Sorry, I messed that one up. Your Y value is now in the front, and that's the first one that becomes the negative. So this one would change. So I have -2, +2. I was wondering why it was not showing up in the correct coordinate. That's also a good way to make sure that you're understanding where your shape should end up. That way, if you mess up, like I know B shouldn't have been down here next to A prime. C is currently at 3, -3. So to get C prime, I'd be switching around -3, 3, but now that Y value is going to become positive. So now I I have positive 3, positive 3. So C prime is where right close to where that B prime was, or the B was, and now as I show my rotation, it has just been rotated 90 degrees counterclockwise. This last one is another rotation, but now it is 180 degrees. This one is probably the easiest one to remember. You still keep the same order of your coordinates, except they just change to their opposites. So if you have an x comma y, you still keep the order of x, y, except they now just become whatever their opposites were. So let's first go ahead and plot the 4 original points to w, x, y, and z. This quadrilateral is taking on the shape of a kite, and what we're going to do now is just take our w's and change them to their opposites. So 2 comma 1 would be w prime, x prime would be positive 1, negative 3, y prime would be negative 3, negative 3, and z prime would be negative 3, positive 3. Okay, so let's go ahead and plot these points and see what we get. W prime is at 2 comma 1, x prime is at 1, negative 3, y prime is negative 3, negative 3, and z prime negative 3, positive 3. Okay, again, this is just a 180 degree rotation. So it's almost just been reversed. Y is now down here, z is down here, x is down here. Do the following shapes have rotational symmetry? If so, describe the rotations, and if not, obviously you say no. For number 16, it's a yes. You can rotate it 180 degrees. Number 17 is also a yes. You can rotate 90 degrees, but you can also rotate every 45 degrees. So we can say 45 degrees, 90 degrees, 135 degrees, and 180 degrees. The last one, unfortunately, does not have any rotational symmetry. If I rotate it 180 degrees, we would see the crossover here, so it's not going to match up. Actually, yes. If I do rotate it 180 degrees, it would end up matching right where it is. So we're actually also going to say yes. This ends up here, and this would end up here. Okay. 19, decide whether the following dilation is an enlargement or a reduction, and then find the scale factor. Remember, to find the scale factor, you're going to just say no. That's new over the original piece. So the new piece is 4, and the old piece is 12. So I go from 4 to 12. Whoops. Sorry about that. Okay. New piece was 4. Old piece was 12. That means my scale factor is 1/3, which means this is a reduction. Okay, so those are the two things we want to say there. Over here, my new piece is 25, and my old piece was 10, and that's going to reduce to 5/2. Since this is more than 1, this would be considered an enlargement. Okay. So there's your answer for that one. You can also say 2.5 because 2 goes into 5 twice with 1 remaining, so it's 2.5. Graph the polygon with the given vertices and the dilation after its given scale factor. So the first thing we want to do is go ahead and plot the original points. So here are my original points, and to find my scale factor, I'm just going to multiply everything by 2. So A prime will be 2, 2, B prime will be 2, 6, C prime will be 6, comma 4, and D prime will be 6, comma 2. Let's go ahead and plot all those new points. A prime, 2, comma 2, B prime, 2, comma 6, C prime, 6, comma 4, and D prime, 6, comma 2. Connecting our points together, you should notice that your figure enlarges by twice the size. This next one is another dilation, except now it is a reduction. So let's see what happens here. First, start by plotting your original points, 2, comma 2, 4, comma 4, and then 8, comma 2. Okay, so here's P, here is Q, and this is R. Now, what's going to happen is P prime is just going to be cut in half. 2 times a half is 1, comma 1. Q prime would be 2, comma 2, and r prime would be 4, 1. So let's see what these new points look like. 1, 1, p prime, 2, 2, q prime, and r prime is 4, 1. And as we show that dilation, that is a reduction of half. There we go. 23, noticing that you do have a negative scale factor, so that means you're going to be dilating it and rotating it 180 degrees. First, let's go ahead and plot our original points. So here are our new points, and all we're going to do now is multiply everything by -3. So -3 times -3 is 9, -6. Y prime would be -6, -9, and z prime would be -3, +3. Okay, let's see what happens to our new points. 9, -6 is going to be all the way down here for x prime. Notice that's a 180-degree rotation. -6, -9 would be my next point, y prime. And then z prime is -3, +3. Okay, as I connect these points together, you're going to notice that your triangle is much larger and it has been rotated about the origin 180 degrees. Okay. 24. Graph the following compositions with vertices at 3, 4, 4, 1, 1, 0, and 1, 2, and then draw the figure after each transformation. 3 polygons is what we should see in total. So first, let's start by drawing the original one. Here's our original figure. Now let's do the first transformation over the x-axis, a reflection. C prime is not going to change. D prime is going to be 2 steps away. B prime will be 1 step away. And then A prime will be 4 steps away. Okay? So all we've done so far is just reflected over the x-axis. Now I'm ready for a translation of x minus 5, y. So we're moving everything over 5 to the left. 1, 2, 3, 4, 5. D prime. 1, 2, 3, 4, 5. A prime. B prime. 1, 2, 3, 4, 5. And C prime. 1, 2, 3, 4, 5. Connecting all our points. You still have the same figure, but now it has just been reflected and translated. The next one we have, again, a composite transformation. So we're going to find out what does it look like for a rotation over around the x-axis, around the origin, and then reflect over the y-axis. First thing we want to do is graph the original points. As we graph the original points, they're making a quadrilateral. Okay. The next thing we want to do is remember what our rotation for 270-degree counterclockwise. I'm going to write it down here. When we do a rotation for 270 degrees counterclockwise, B and A switch places, but A is the one that gets the negative. So that means if your x and y values, they are being switched around, but your y value is the one, or sorry, your x value is the one that's getting the negative. Okay, so let's go ahead and see what that will look like if we rotated that and changed all of our points. So A prime would switch the 4 and the 3 around, but the 3 would become negative, so 4, -3 is going to give us our A prime. For B prime, 1, 4, but the 4 would be negative, so B prime would end up here. For C prime, 0, 1, but the 1 would become negative, so here would be C prime. And then D prime, the 1 and the 2 switch around, so 2, 1, but the 1 would become negative, so 2, -1. Okay, this again will show our rotation of 270 degrees about the origin. Now, all we're doing next, oops, I did D wrong. 1, 2, I should have 2, -1. There we go. We're good. Now we're just going to reflect over the y-axis. Again, here your y-axis is here. It looks like C is already there, so C double prime will also share the same point as C prime. D prime is only 2 steps away, so we'll be 2 steps on the opposite side for D prime. A prime is 4 steps away, so 4 steps away on the opposite side. And B prime is only 1 step away, so only 1 step away for B double prime. Connecting my points, I should see a clear reflection of A, B, C, and D primes to A double primes, all the way through D double primes. 26. In the diagram, a reflection in the line of map CDE to C prime, D prime, E prime, and then that reflection is reflected over line B to make all the double primes. The distance between lines A and B is 8 millimeters. Find the distance for D to D double prime. Remember, all you have to do is take 2 and multiply it by this distance, so the distance is 16 millimeters. Same thing for here, but now we have those angle measurements. If I want to go from point L to L double prime, that's taking your 80 degrees and multiplying it by 2. So 2 80-degree rotations, because technically this would still be an 80-degree rotation, would be a total of 160 degrees. Okay, that concludes your final review on Chapter 4. Thanks so much for tuning in. Good luck on your test. Give this video a